Okay, welcome to the first physical class of what we call material science for chemical engineer. So this course is basically the introduction course for material science lah. Previously, we have other lecturer from material department teaching you material science. But starting for this CHEN batch, you are second batch for the third batch for the CHEN. The kuliah asked the person from the department itself, for example, I am from the CHEN department, to teach the material science. So the difference between this and previous material science is that we include the chemical part. So you will see along the way, I will include or instill some chemical story when I deal with when I talk about the material. So typical material course from material department, they not touch much on the chemistry part. They touch about the material, the material itself lah. The crystallography and so on. But the chemistry part, they do not touch a lot lah. So for today's class, it's about the presentation by your friend. So we have 6 presenters today. We have Amirul, we have Alif, Fikri, we have what we call Adi, Haikal Hadri, Adi. And we have Raudhah, Wan Ain, and also Arinah. Okay. So this presentation will give you some overview about the metal, ceramic, and polymer. These 3 material is what is the basis of the engineering material lah. There are other material like wood, this wood, right? This wood is also material, but this natural material. So when in this class, we focus on the engineering material lah. I want to see whether you can see or not at the back. Engineering. Can you see at the back? Siapa nama kat belakang? Adib. Haziq. Can you see? Yeah. Engineering material. Engineering material, which comprised of 3 things. We focus 3 things only, which is metal, and then polymer, and also the ceramic. Okay, and we will focus more on polymer, because polymer have a lot of things, have to do with the chemistry. So we focus more on this part lah, polymer. Although metal and ceramic also have chemistry by itself, but it's not as not as much as this polymeric material lah. Okay, so without further ado, I will ask Amirul to give his presentation. Amirul, you can come forward.
Hi, good morning. My name is Amirul. So today, for my presentation, I'm going to talk about metal. So first of all, what is metal? So metal is actually an element, compound, or alloy, and most of the elements of the metal, most of the elements in the periodic table are metals. And so in periodic table, right, so we know that we have a variety of types of metals. So first we have alkaline metals, which is from group 1 except for hydrogen. And then also we have alkali earth metals, and they are from group 2. And we also have transition metals, which is from group 3 until group 12. And we have poor metals, like group 13, it starts from aluminum and downwards. And group 14, it also starts from germanium and downwards. And group 15, it starts from antimony and downwards as well. And lastly, we have group 16, which starts from polonium and downwards. And also, another 2, we have lanthanide series from group 3, which is like the other one yang bawah tu. But also actinide series from group 3 as well. And so we have few properties of metals. I think like there are more, but I'm just gonna tell you like the mainstream one, the sixth one, which is metals, they are shiny, and they are also ductile, which means they can be deformed and without breaking its shape. And also metals are malleable, which means they can be hammered or like can be pressed without like breaking the shape as well. I'm sorry, but by the way, the ductile means that it can be deformed, but the toughness will still be the same. And also, metals, they have high melting point. And like metals, so they are like a good heat conductor and also electrical conductor. And lastly, the properties of metals. We know metals, they react with water and oxygen to cause rust. Okay, so I don't know why I chose these metals in electrochemistry, because when I was in high school, this topic, I kind of like this topic during my chemistry class. So I'm just going to talk about it. So metal in electrochemistry, let's say we use electroplating, which means, so to do this electroplating procedure, we will need like a cation and also an ion. No, I mean like the reactive metals and not reactive metals. So for the metals like copper, we'll put it at the anode side, okay? And the other metals like iron, we put it at the cathode side, this way. So, like copper, they will like, when we, what's the word? When we like submerge this in the copper to sulfate solution, which is in blue color, this copper plate will dissolve and it will form copper ion. And then the copper ion will be deposited into this nil ion. And hence, the nil ion will be electroplated by the copper. That's 5 minutes ago.
It's okay. You can take your time.
Okay. Yeah, I think that's it for me. Thank you.
Okay. Stay safe for a while. What we call Amirul. Okay. So now I want the class, one person, to ask question related to this to see whether you understand or not. So please ask Amirul one question, and then Amirul, you can also ask one person, but you choose people who want to ask. Okay. You choose which one is your victim. Okay. But first, the audience ask the question first to Amirul related to this. Those who ask the question, no, cannot get marks because asking the question doesn't count. Okay. If so, not, I just pick the name.
Who wants to ask question? Okay.
What is lanthanide series and ethanide series?
You know, like at the periodic table, we have the common one at the top, right? And this series, they are at the bottom. Like we didn't really learn it during chemistry previously, so like I myself don't know, haven't studied yet, but just know the name recently when I was making like the research to do this presentation. So I would like to ask Farah, what would it be? Can we like react? I mean, can we like, what would it be if we react this alkaline metal with water? What would it be? What's the product? If you react any of the alkaline metal here with water. Yeah, what's the product? Okay, let's say, can you give that one of the example for that chemical equation or something? You can actually write over here. Choose any alkaline metal in group 1.
Normally when I ask in the online class, nobody will answer. But now Amirul can see you. So they will see your reaction. So that's also what I will do in the class. If people don't volunteer, I just pick the person and then, yeah. If I pick the person, then they are no bonus mark lah. Okay, Farah nama. Okay.
Metal hydroxide and oxygen
Yeah.
gas.
Accurate. Yeah. I think that's it.
Okay, thank you Amirul.
Thank
So
you,
now you can
Farah.
pass the microphone to Raudhah.
Bye.
Okay, as you can see, it's not easy to give presentation in front. All of you who don't presenting, sit comfortably on your chairs and listen and so on. But when you come in front, you need to, what we call, a lot of things happen. You need to remember what you need to say, you need to engage with the audience, and also you need to make sure, the most important thing, you need to make sure what the message that you want to give is relate to your audience. It's as if you want to bring what inside your mind to the mind of your audience. So that itself is a difficult part of the, what we call, public speaking lah. This is kind of public speaking. In fact, I think most of us, including me, afraid of this public speaking because we don't confident. That's why if I put the camera, then you will sort of like reflect back later on. So I starting recording myself when the pandemic start. Okay, because during that time you have online class, and then for online class, some student cannot, what we call, don't have data. Maybe internet is not what we call not good enough. So then I need to record myself in order to cater that student. So starting from that, I mean slowly and what we call surely, then I think I'm okay now with the in front of the camera. Previously, I never record myself, but now it's time for Raudhah to present. I don't want to take more time. Okay, Raudhah, your turn. On metal also. Let me change the thing to Raudhah. Yep, that's Raudhah.
Okay, Assalamualaikum and hi everyone. So today I'm going to present about metals also, but my presentation is quite different from Amirul a little bit. So Amirul already explained to you the physical properties of metal. So today I'm going to explain the types of metals, which is quite different from Amirul's, and also chemical properties of metals. So there are 5 types of metals. The first one is ferrous metal. Ferrous metal is actually iron that combined with carbon. So there are 2 types of ferrous metal. One is cast iron and one is steel. So the cast iron is metal that has higher carbon content than iron carbon content. So it is more ductile and more corrosive resistant. Means it's it corrodes. Less corrosive resistant. More corrosive resistant. So the second one, steel, contains higher carbon content and lower higher iron content but lower carbon content. I'm so sorry. So this one is less corrosive resistant. So do you need me to write? Like, if you can see here, this one is have more carbon. This one have more iron. So when you go here, it is more ductile and more corrosive resistance. But if you go over here with more carbon, it is brittle, which is a little bit fragile and less corrosive resistant. But if ductile, it is stronger, so it's more used in construction. But for brittle, it is less stronger than the ductile one, so it is less common in construction. So the next one is non-ferrous metal. Non-ferrous metal is basically metals with no ions present in it. So that is, I think it's less common in construction also because it's not as strong as ferrous metal. So the next one, noble metals, it's like noble gas also. It's less reactive in liquid or in powder forms. The fourth one, heavy metals. Please don't get me wrong. Heavy metal is not the rock genre song. It's type of metal with high atomic weight and high density. But it is less strong and less strong than the other metals. So the last one is metal alloy. So it's a combination of metal to get your desired properties like stronger properties, or maybe stronger, more durable, something like that. So now I'll go to the chemical properties. The first one is reaction with oxygen. So as you have learned in chemistry, metal will react with oxygen to form metal oxides. Like the most common one in group 1 is sodium. When you react with oxygen, you form sodium oxide. But for aluminium and zinc, they will form amphoteric oxide, which means oxide that have both basic and acidic characteristic. So the second one, reaction with water, like Amirul asked for us just now, what is the product of reaction with water? So when water react with metal, it will form metal hydroxide plus hydrogen gas. So the most common one, like I'll take what now, potassium. When react with hydrogen, we form potassium oxide and also hydrogen gas. But like this metal, this common metal, like potassium, sodium, they react with cold water. But if for magnesium and zinc, they react with hot water to form oxide and hydrogen gas. So it means when magnesium react with water, it will form magnesium oxide and also hydrogen gas. Okay, so moving on, we have a reaction with dilute acids. Dilute acids are the most common dilute acids we use are hydrochloric acid and also sulfuric acid. So reaction with this dilute acid will form metallic salts. Like for example, when sodium react with hydrochloric acid, will form sodium chloride and hydrogen gas. Do you need me to write on the board or you can follow? Good? All good? Yeah. Okay, so the second last, reaction with metallic salts. So metallic salts is basically the salt that you have produced after reacting with water. Like just now we have produced sodium chloride. So I'll take this example, but this one I'm using zinc and also copper. So actually for this reaction, the more reactive metal will displace the less reactive metal. So okay, for example, you take copper sulfate, react with zinc. So the product is zinc sulfate plus copper. So as you can see here, the zinc displaces Cu. The zinc, which is more reactive, displaces Cu, which is less reactive. Okay. So actually, this process is also called displacement reaction. Are you guys following me? Are you guys good? Okay. So this is the last part, reaction with hydrogen. So metal will react with hydrogen to form metal hydrides. But very few of the metals that react with hydrogen. So, like the most common one are sodium and potassium. That's the most common one. So when like sodium react with hydrogen, they will form sodium hydrides. Okay. Do you guys have any question? Yes.
Can you like tell me the example for heavy metals?
Heavy metals are the example arsenic, cadmium, and mercury. Yeah. So it's heavy metals are some of it are quite toxic, like mercury. You cannot just.
Are they from periodic table?
Yeah, they're from periodic table. Yeah. Do you guys have any more questions?
Is it all metals is electric conductor, including metal alloy?
Not all metals are electrical conductor. electric conductor. Like there are some metals that are not electrical conductor. Such as I'm so sorry, I haven't do the research on this. Like, okay, do you guys have any other question? No, okay. I think that's all, Doctor.
Okay, thank you, Raudhah. You can stay for a while. Okay, about the question by what's this one? No, Amirul, the second one. Aiza. Aisa. Okay, Aisa asks if all metal conductive. Okay, is there any metal that is non-conductive? By definition, metal is almost all metal is conductive to a certain degree lah. In fact, if you see in periodic table later on, I will show you. There are some conductivity to all of them, but for example, something like non-polymer, non-metal thing like oxygen, of course we don't see it as conductive, right? Even the silicon by itself is not conductive, but there are some conductivity inside that. So if we dope that silicon, if we add something to that silicon, it becomes that's why silicon is semiconductor. They call it semiconductor because there are some conductivity, but they are not as conductive as real metal like what we normally understand lah, like copper, zinc, whatever lah. So for every element in the periodic table, there are some conductivity, but the level of conductivity can be very low to the point that the electron cannot flow around lah, because to make thing conductive, for example, let's say this metal, let's say the metal that Raudhah said, example like what example of metal? Mercury. Any metal that's normal lah, normal for conductive. Sodium has some conductivity, but let's take something that is common to you, like copper in the wire, because sodium you don't use sodium in the life, right? So like copper wire like this, in order for this electric to move around, you need to make sure the electron can move around, right? Okay, so for that, you know the atom, let's say this the center of the atom, and then the electron surrounding the thing. So if let's say the atom, let's say you have this copper atom here, copper atom and the nucleus here, nucleus. If let's say this electron cannot move, for example, the electron is bound to the atom, right? If the electron just bound to the electron, then it's very hard for it to make conductive. Okay, so in order for the electron to flow, the electron must be free. They must be able to like free lah. We call it delocalized electron. Delocalized electron. So the conductive, the ability to conduct electricity is when you have the electron is free to move around the lattice. The lattice lah. Because metal, inside metal, typical metal, they are having metallic bond. Metallic bond. In polymer, they don't have this. They have covalent bond and so on. So because of this metallic bond, electron freely move here and there. That is cause what we call this have conductivity lah. So that's the reason why metal, due to this metallic bond, almost all of them is conductive. I don't know which metal is non-conductive. I don't know, not come to my mind lah. Yeah, not come to my mind. Any metal that is non-conductive. If we talk about metal, normally we associate with the conductivity. Okay, so Raudhah, you can pass to Alif Fikri.
Okay.
Okay, Alif Fikri, we talk about ceramic. Ceramic. So now we have the ceramic. This is yours. Is this yours?
Yeah.
Okay. Okay, Alif Fikri, you can start.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today I'm going to talk is about ceramic. Okay. First of all, what is ceramic? Ceramic definition of ceramic is a various hard, any various material, brittle, heat resistant and corrosion resistant material, such as clay, that we shaping them and firing with an anorganic material, and we firing it at a high temperature. So the characteristic of ceramic that we know that ceramic is very hard. It's a chemical inertness and heat resistant and have a high melting point. And ceramic also low electrical and thermal conductivity. And lastly, ceramic is considerable durability. So it means ceramic is a tough things. So and I'm gonna present this one first. The type of ceramic. Ceramic have three types. First of all is earthenware, which is a clay that fired at relative low temperature, which is between 1000 and 1150 degrees. And after the firing it, they glaze it with the cover, the object, before it fire into the kiln. The kiln is a action that we burn the clay to become the ceramic. And for this earthenware, the ceramic of earthenware is not waterproof. And then that's all. And then the stoneware which is fired by a more heat, which is a higher temperature, which is 1200 Celsius. And the result of the ceramic that we get more durable material with a denser stone. It means that the ceramic will become more tough and sturdy. So the finished product will be waterproof, not like the earthenware, which is not waterproof. And the last type is porcelain. Porcelain is a refined clay that which fired with the highest temperature, which is 1200 to 1450 Celsius. The result of the ceramic is extremely hard ceramic, and become shiny ceramic. And often of the material is white and is translucent in appearance. So for the example of application of ceramic in our daily life, first of all is brick. As we know, the brick that we use to build the house and the building, that's an example of ceramic. And the next one is cement, like also used to in the building. And the floor tiles, which is an example of this floor, which is made of ceramics. And next one is the medicine, which is used for morphine and kaolin, which is used stomach ache. Right. The last one is pet waste industry, which is for example that like our cat in the house, we use specific sand that will absorb the poop and pee, right? The cat poop and pee. So that things is also made of ceramic. Boleh nak cepat. I think that's all. Have any questions?
So one question or maybe any question lah from the floor. And then you, Alif, you ask question. You choose person who didn't ask, then you choose that person. Don't choose those who are talking.
Okay.
Choose those who are not talking. Okay, so now the first question first from the audience.
Okay.
Do you know application in daily life, right?
Yes.
Do you know that what type of them? Like
What type of them?
Earthenware or stoneware? Do you know?
I'm not actually sure, but based on what the application that I taught, I think I can just put it in the like my logic things like brick and cement cannot absorb water, so maybe the earthenware. Like a floor that we know the floor is very hard, so maybe it's in the stoneware. Like medicine and pet waste is very not waterproof, so I put it in the earthenware. But I'm not very sure about that. Sorry. Any other questions?
And now you ask question.
Okay.
You choose person, sister or brother. Up to you.
I want to ask Brother Zaim. What do you think about the corrosion resistance? What is the mean of corrosion resistance?
Resistance from corrosion?
What is you mean?
That's correct, actually. But you need to explain further. The question is that you should say that explain further about this term. That's only then Zaid will talk a lot.
Maybe
Yeah, corrosion means is like hakisan. So what's corrosion resistance? It mean in the more detailed terms. Like what?
I think when the ceramic react, I mean when ceramic are exposed to something, in my opinion, acid or something that may have corrosive, so it won't affect at all.
Okay, thank you.
From your opinion,
Okay, that's quite right.
Okay, just to tell you, for it's okay, you stay for a while. For the first batch of CHEN, you are third batch, the midterm I conduct it oral, meaning that like now. Like now, for example, one person come to me online lah. For example, let's say Arinah in front of me. Okay, the first question, blah 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 blah, and Arinah must to answer like directly because that batch only have 4%. So I able to do this what we call the face-to-face oral midterm. So this kind of the oral midterm is actually far more difficult than the written exam lah, because written exam you have time to think and so on, but oral it will sort of like attack you straight in the front. But in reality is that what happened lah. People will ask you directly. People will not wait you to write and so on. So the ability to answer and ask the question is also the skill that you will build up during this course or any course lah, while you are in this university lah. Because once you go out in the real life, no, this also real life. When you go out working, that's you need to have both the written and also the oral. Okay, this Alif talk about ceramic. One of the defining characteristic of ceramic is it is brittle. Okay, you see there they are brittle, right? What is brittle? Well, hard and brittle. Okay, hard doesn't mean strong. For example, this mana? This. Ini metal. This is metal lah. Metal we don't call it hard. Okay, we don't normally call it hard. We call it strong. Strong or ductile lah. Siapa tadi? Raudhah said ductile lah. Ductile mean if I have this and I try to kepak apa dah maksud this? Then it's not kepak, then macam ni. Snap. Try to snap it. It will just pop like that without any warning. But for metal, if I try to do that, of course this is not mine, so it will sort of like bend like slowly lah. Oh, I heard den just now. That's why I said. You said bend. Huh? Den. Oh, den is not kepak. Den is you just poke like that and then make some den lah. Kepak is making it like that lah. You know lah what I mean. So basically for the metal, if I do that, for example, if I throw that, it will not shatter. It will just sort of like dislocate. The atom inside the metal dislocate, and then you can see, you can sort of like make it malleable or ductile. That's the term of metal lah. But for ceramic, let's say you have a brick, right? A brick, this brick, and then you try to do that, it will not give you a warning. It just crack like that, just straight away. So that is the term brittle lah, meaning that there are no warning before fracture. It's brittle. This metal, people use it for the construction because you can see the warning. You go the car moving on the bridge, and you see that the bridge somehow sort of like dent a little bit. So at least people on the side see the bridge sort of like this lah. Somehow you can see the bridge somehow dent when the car move. If the enough more weight is on the bridge, then you can see the metal will sort of like show its ductile property lah. But if you use ceramic, then without any warning, it will just break like a concrete lah. Concrete. That's why concrete is a ceramic, but the structure that you see normally is the concrete plus something. The structure that you see is the concrete, and then inside the concrete they put something. They put metal. They put metal, right? That's why you see in any construction they have the concrete, and then in the middle there are metal, cerucuk tu. Because they want to utilize the ductility of this, and to mitigate the brittleness of the ceramic, which is the concrete here. If they don't put this, then you will, if there is any calamity, the bridge or whatever jalan raya will sort of like snap just like that without any warning. But if you have this thing, if let's say the load is applied, very high load is applied beyond the capability of this concrete, what will happen? You will see there are crack. The crack will happen. You will see the crack, but then when the crack reach the metal, it will dissipate. So the engineer will have more time to see, because they can see the warning from the crack. Because the crack is arrested, they arrest by this what we call this metal. The metal spread the crack and so on, and that's why reinforced concrete, we call it reinforced concrete, because we use metal to reinforce the concrete. They use it in the structural building and so on. So now Alif, after Alif, who is the Arinah? So you can pass the mic to Arinah. Arinah also we talk about ceramic.
Yep.
Okay.
Mana tu nak buka?
Siapa nama tu? Fatimah. Saya pangkat. Siapa nama you? Di ujung sekali. Kainisa. Fatimah pula. You nampak? Okay. Okay, so Arinah. So Arinah is quite big.
Mana ni? Selit. Oh, sini lah.
You boleh klik dekat you punya ni, you punya metric card tu.
Okey. Jatuh.
Okay. Okay, because your presentation is like vertical like that. So if you want to go down, just tell me.
Alright.
Okay.
So hi, good morning everyone. I'm gonna continue with the same topic, which is ceramics, that have been presented by Irfan. But some of the information are
Alif Fikri.
Sorry, Alif. But some of the information are quite the same as what Alif presented. So I'm just gonna repeat the same lah. Okay. So first of all, I would like to introduce ceramics in our daily life. Okay, so actually ceramics bring a lot of benefit to us, and also we actually live with it. For example, like we live in a house. The element to build a house like bricks, cements, glass are made from ceramic. Other than that, when we drink water or coffee from a mug, also made from ceramics. So actually, ceramics give a lot of benefit to us, and it has existed for 1,000 years. Okay, so I would like to tell about the definition of ceramic. It is an inorganic non-metallic solid made up of either metal or non-metal compound, and it's shaped and hardened by high temperature. Okay, so in general, ceramic is hard, corrosion resistant, and also brittle. Like what Dr. said, brittle. It's hard, but it can be fragile, such as the example of ceramic that brittle are glass and also porcelain. Okay, so Next, the types of ceramic. There are two types of ceramic. One, traditional ceramic, and the second is advanced engineering ceramics. Okay, so I would like to explain more about the traditional ceramics. The traditional ceramics are also known as pottery. Okay, so it actually one of the oldest human technologies, and it was clay-based. Clay-based, and it's just a containers that made from clay. Okay, so the major type of pottery or traditional ceramics are described as earthenware, stoneware, and also porcelain. So the main point of the comparison between these three are the temperature, the resulting strength, the water resistance, and also the durability of the final products. Okay, so the first one is earthenware. The temperature is 1000 to 1150 degrees. It hardened but brittle material, slightly porous. So it's quite fragile. Other than that, it's easier to shape, but have a higher water absorption. So next, the stoneware. The stoneware is the temperature is higher than earthenware, and it's more durable material. It's a stone-like quality and also waterproof. For stoneware, it's more durable, and then it's more versatile. So it can use for a lot of things, and it's also suitable for use for kitchen equipment. Like for cooking, for baking, and also for serving dishes, because it kind of had heat resistant also higher. So for example, stoneware, it can use for coffee mugs. Okay. So next is porcelain. Porcelain, it can use for very high temperature, which is 1200 until 1450 degrees. It's extremely hard and shiny material, but porcelain is more to white, translucent ceramic. And it's also commonly used as tableware at house, like that. So next is the advanced ceramic, but that one I didn't explain in the slide. Okay. So advanced ceramic is more to product that made from inorganic, high purity compound through a series of specialized manufacturing process. So the difference between advanced ceramic and also the traditional ceramics is these advanced ceramic are not generally clay-based, and also it based on oxides and also non-oxides. So there are two oxides.
Do you see that? Siapa belakang tu? Fatimah. Sebab Fatimah semua. Siapa nama? You pakai. You. You.
Can you see this?
Siapa nama? Adeline.
Adeline.
Can you see? What is that?
Oxide.
Okay.
Oh.
Sometimes students just you need to make sure they see.
Okay, so for advanced ceramic, it based on oxides and non-oxide. So example of non-oxide is like carbides, nitrites, silicides, and for oxides is aluminum and ZrO2. These are the example of oxide and non-oxides. Okay. So next, the difference of advanced ceramic and the traditional ceramic is from raw material. For example, advanced ceramic, they made using made using synthetic powders such as aluminum oxide and also silicon carbide and others. So for traditional, it only use from natural materials. Next, the difference is the manufacturing process. So for advanced ceramic, they require an additional post-sintering process. There are a lot more process than the traditional ceramic. So kalau for traditional, there's no any additional process other than the high temperature sintering of traditional ceramic. I think that's all.
Okay, any question from the floor? I think because just about the type, I want to interrupt for a while. About the type here, for me, this is not type of ceramic. This is more like pottery, because glass. Where to put glass there? Because if I have Google, let's say, Mr. Google there, I bring Mr. Google there, and then if let's say I put a tinware there. So is earthenware or whatever is under type of pottery. So if I go to image, so that is earthenware, something like this. This earthenware, okay. So it's like a terracotta. We call it something that is not purely. There are some porosity lah. For example, pasu vase kan, vase yang warna orange ni. If you siram.
Water.
Water the plant whatever in that waste, you will see the water coming out. I mean, you can seep through this inside the earthenware. So that is earthenware. So let's see stoneware. What is stoneware? That's earthenware. Okay. Normally it's color orange like that. That's earthenware. So that's earthenware. So this is pasu bunga. And then we use stoneware. Stoneware. Okay, let's see. Stoneware like this. The color, you see the defining difference is the color lah. So you can see that the stoneware is more like glazing. They have like glazing. We call it like glaze lah. For example, the mug that you buy in the Mr. DIY whatever, you can see outside that thing. They are like a glazing, like something like shiny thing, like that thing. Normally, stoneware they do for glazing, and they do glazing lah. So you can see this stoneware, example of stoneware like that. Stoneware. So and then porcelain, you know lah. Porcelain. So porcelain, you know, is the whitish thing. Okay. So the difference between this and earthenware, stoneware, and the porcelain is the how high the temperature they bake the thing. Okay. So you can see this stoneware, this porcelain is the most durable one among all lah. So this stoneware, earthenware, and porcelain is basically the types of pottery. Pottery is under ceramic. Ceramic, the classification of ceramic, we can see because glass also ceramic, but glass doesn't include here. This all something pottery lah. So earthenware, this thing is pottery. When we talk about ceramic, normally we think about pottery lah. Glass also ceramic, but it's not a pottery. Okay, I think thank you, Arinah. So we move on Adi. You can give the mic to Adi. Adi, we talk about polymer. Okay. Okay, that's polymer. That's yours, right? Adi?
Yes.
Okay, Assalamualaikum. Saya will present about polymer. Before we start into deeper, let's start with the definition of the polymer. Polymers are a very large molecules made when hundreds of monomers join together to form a long chain. Monomers is something is like string or ester, but when it make a bond with other ester and create a chain, we call it as polymer. Basically, a polymer is a bunch of monomer. And the characteristic is it is usually high strength or modulus weight ratio, which means it is very light but it is very strong. High resilience, high resistance to corrosion, and lack of conductivity, heat, and electrical. And it is also low cost. That's why we usually use polymer as a product nowadays. So can I?
You can.
Okay.
Up to you. That's your presentation. Up to you. You want to do whatever you want.
Okay, that's one thing that is not here in this slide. That is the type of polymer. So polymer basically have three types. One is what you call it? Sorry.
Elastomer.
Elastomer. Elastomer. Another one is synthetic. And the other one is natural. Natural.
Maybe you can use other pen because this is not that pen, blue pen, because this pen is the class 1, so it's not clear.
Okay, and under synthetic we have two more. That is the thermoplastic. And the other one is thermoset. Okay. So basically, polymer is around us. Our shirt is made of polymer. Our body is made of polymer. Our DNA is also made of polymer. Natural in polymer, the example for natural in polymer is our DNA. We learn it in biology. For those who took it in Form 5, DNA polymerase and almost all of the amino acid polymer and the enzyme in our body is made of polymer. Also, in my slide, the web is amino acid polymer. The sheep wool is a keratin polymer, and DNA is DNA polymerase. For elastomer, usually a rubber that we use. The example is like neoprene. Neoprene is usually we use it as our swimming suit. Our swimming suit is made of neoprene usually. The other one is synthetic. Synthetic separated into two types: thermoplating and thermosets. Thermoplating, right?
Sorry?
Thermoplating.
Thermoset, and actually another one is thermoset, and one more is what?
Thermoplastic.
Thermoplastic. Yeah, thermoplastic and thermoset.
Silap. Thermosets and thermoplastics. The thermosets one cannot be melt and thermoplastic can be melt. The thermoplastic can be melt. And under the thermoplastic we have two more. That is semi-crystalline. Semi-crystalline. And the other one is amorphous. So the semicrystalline and amorphous is basically the chemical bond. The amorphous have no structure, and the semicrystalline have structure. As you can see there, this example of synthetic polymer is, the shirt is polyester. The swimming cap is the neoprene, and the other one is what we usually use in our daily life, polystyrene. So that's all for polymer.
Okay, any question from the floor to Adi?
Any question? Yes?
Can you explain a little bit more about
High resilience. High resilience basically means it is highly durable, tahan lasak. Okay.
Okay, Adi, ask one question. Take one person and ask.
I will open the floor for anyone to answer my question. My question is, the polypeptide and polypeptone that we learn in biology form 5 is a type of polymer. Zaim?
You said like that, people will not respond. You need to pick the person. It doesn't work.
There's polypeptide. Yes.
Okay. Okay, thank you, Adi. So now we move on to the last presenter, Sister Wan. Sister Ain. Okay. Okay, Sister Ain will explain further about polymer. So this is for Sister Ain. Okay, Sister Ain, when you want to go down, just tell me, I will go down.
Okay.
Okay.
Okay, Assalamualaikum warahmatullahi wabarakatuh. I will explain about polymer. Same as Adi, but I explain more about the uses in daily life. Okay, poly stands for many, mer stands for units. Polymer are micromolecules formed by the chemical bonding with large number of repeating units called monomer. Nampak? Nampak ke? Nampak? Okay. Ni macam visual representation yang simple lah. Monomer, polymer, repeating unit. Okay. Polymer also has become the raw materials that we use now in our daily life, such as a plastic bag that are made from polyethylene. But why do we use polymer, not other material? Two of the reason, polymer can be reused, and some of them can even be recycled. Other than that, the processing of polymers can be very easy compared with other material. Okay, now let's move on to the types of polymer. The main type of polymer, which is synthetic and synthetic and natural polymer. First, synthetic. Synthetic polymer can be obtained by polymerization of petroleum based on raw materials, or we can say that synthetic polymer is a human-made polymer. under synthetic polymer, there are three principal classes of properties of polymer. Actually, I made mistake there. Elastomer tu can be both synthetic and natural. Okay. First, thermoplastic. Thermoplastic that can be melted and reformed. Example of thermoplastic, polystyrene, PVC, nylon, and more. I will explain about polystyrene. There are various applications of polystyrene in our daily life, in manufacturing, and also packaging field. Disposable cutlery such as polystyrene cups, polystyrene yang untuk makan tu. And for packaging, if you have ever ordered something online, gambar kat bawah. They will include this in your box to protect your item from broken lah. Next is thermoset that can change chemically on heating. The example of thermoset is backlight. Did I pronounce it?
Backlit.
Backlit.
Whatever.
Backlit.
That doesn't matter. But do you know backlit? What is backlit? It's okay. I will let this sister Wan finish first, and then Mr. Wan will explain.
More example of thermoset is polyester. Okay. First about backlit. Fun fact about backlit is the first plastic to ever be made entirely out of synthetic polymer. It was first developed in 1907 by the Belgian-American chemist Leo Baekeland in New York. It's named after him, Baekeland. Okay, I think this. Have you ever seen this? This jewelry bracelet. It is made from bakelite.
You see that thing before?
Have you?
No.
No. No.
You tanya brother mana nampak? It's okay.
Pernah nampak?
Bukan, mana dia orang tahu sangat sebab dulu. That's okay. You can continue.
Okay, I think this kind of jewelry became popular in 1930, 1940, and until now, I still can see this everywhere.
I don't see it.
Okay, next type of polymer is natural polymer. Natural polymer is obtained from different renewable resources. It is found extensively in nature. Our body too is made of many natural polymer like nucleic acids, proteins, and more. Another example of polymer is latex. Latex occurs in both forms, either natural and synthetic. The natural form of latex is mainly collected from rubber tree. Okay. Okay. Not everything is perfect. Polymer also is its own disadvantages. Most of these polymer are non-biodegradable, which can harm our environment because, especially plastic bag, they don't break down easily. If it's not disposed properly. Some of polymer also can degrade on sunlight and some radiation. When polymer are burned, they emit a lot of poisonous gases into atmosphere, which results in choking. As you have seen, polymer is not a single compound. It has a large variety. It's all different forms of polymer comes under one umbrella. That's all for me. Thank you.
Okay, thank you, Wan Ain. Terengganu eh? Terengganu?
Kelantan.
Kelantan. Okay, backlit because just now the brother doesn't really, we don't really see that thing. So let's see backlit because once you see the thing, then it's much easier lah backlit. Backlit. Okay. Also this thing.
Have you ever seen the old phone like this? Yeah. So this phone, the old school phone, normally if you try to hold it, it's very heavy lah. It's not like a modern phone, which is ringan, lightweight, and so on. But the old phone, like this phone, is quite heavy lah. It's not steel, it's not metal, but it's made of plastic. This is one of the first plastic that's ever developed. This backlit is a thermoset, meaning that if you take this phone and then you throw into fire, it will degrade. You cannot reuse that. If you have plastic bottle, you can go do recycle, right? You can basically recycle. Basically, they try some of the way to recycle thing is that they melt the thing and then they reuse again. This phone, because it's thermoset, if you throw into fire, it just degrade. Sometimes when you take plastic, when you have a lighter, you try to to lighter this, to heat this, to burn this plastic, you see the black thing coming out, right? That's nothing to do with the thermoset or thermoplastic, because this is a thermoplastic. By right, if you heat, you can use that back to remold and make a new plastic. The reason why you heat and then it become black is because the temperature is already beyond the thermoplastic temperature. Meaning that in order to remold, to make this and get a GUI and use it again, you need to heat it in such a way that it's not too high. There are certain temperature lah. When you do with the lighter and then coming out the blackish thing, whatever, that is you reach the degradation temperature. It degrade already, so you cannot use lah. But this normal plastic is basically thermoplastic lah, meaning that you can send to the recycle, whatever, and then you can get the material and reuse it to make a new plastic. Okay. So thank you, Wan Ain. Okay. So basically that's it for today. Today you learn. I give you the overall view about the engineering material that you will learn throughout this course. There are 3 types, which is the metal, the polymer, and also the ceramic. Okay, I will focus more on the polymer, and metal and ceramic. We will study that, but not as deep as polymer part lah.